Alright, hackers and hackerettes, welcome to a new video in our series, the TryHackMe Pre-Security How the Web Works series. So if you haven't been watching these in sequence, please do. I do have a playlist on my YouTube channel called TryHackMe Pre-Security How the Web Works. So make sure to watch these in sequence so you get the full context of this thing. Previous video, we talked about DNS, and right now we are going to talk about HTTP in detail. So let's get started. What is HTTPS? So HTTP, or Hypertext Transfer Protocol, is what's used whenever you view a website developed by Tim Berners-Lee and his team between 1989 and 1991. HTTP is the set of rules used for communicating with web servers for the transmitting of web page data, whether that is HTML, images, videos, etc. What is HTTPS? Hypertext Transfer Protocol Secure. HTTPS is the secure version of HTTP. Data is encrypted, data is encrypted, so it not only stops people from seeing the data you're receiving and sending, but it also gives you an assurances that you are talking to the correct web server and not something impersonating it. Okay. So what does HTTP stand for? Hypertext Transfer Protocol. What does the S in HTTPS stand for? That's secure. On the mock web page, on the right, there is an issue. Once you've found it, click on it. What is the challenge flag? Okay. Oh, there it is. Invalid HTTP cert. So yeah, once you see this icon, you should worry. Like on your Google Chrome, it should be like in place here instead of this, but because this is requesting for permissions and stuff like that, this is why it's going to look like that. But if there's a problem, Chrome is going to change this icon to look something like this. So click it and investigate. If you're not sure, then do not visit the website, especially if you see it like on something like a social media or your bank or something like that. Probably it could be hacked or something. So just be careful if you see the icon where you should not see it. Right, requests and responses. When we access a website, your browser will need to make requests to a web server for assets such as HTML, images, and download the responses. Before that, you need to tell the browser specifically how and where to access these resources. This is where URLs will help. So URL is Uniform Resource Locator. If you've used the internet, you've used the URL before. A URL is predominantly an instruction on how to access a resource on the internet. The below image shows what a URL looks like with all of its features. It does not use all features in every request. So you have the scheme is the HTTP or HTTPS. Also defines the protocol here, by the way. So we have a user and a password. If you have a user and a password, you have a host or a domain, something like TryHackMe, and then you have a port. The port is inferred from the scheme unless explicitly like defined right here. So if the port is not the standard, so for example in this case, since we're running this in HTTPS, the default port is 443. This is why I don't have to add 443 in here, right? It is automatically like stripped out and removed. But if I try to access it on like a different port, let's say 9090 or something, then it's gonna like tell me that this port does not exist or what the heck you're doing, right? So it's gonna like load for a while and then it'll probably tell me like that you're in the wrong place, buddy. So this is why you don't usually see port 80 or port 443. It is implicit from the scheme that is used here unless it is not running on the default port. Then you have a path. A path is something that is like that. And then you have a query string and you have a fragment. Okay? So this is what a URL looks like. Cool. Scheme this instruction what protocol to use for accessing the resource, such as HTTP, HTTPS, FTP, and so on. User. Some services require authentication to log in. You can put in a username and password into the URL to log in. Okay? Host. The domain name or IP address of the server you wish to access. Port, the port that you are going to connect to, usually 80 for HTTP and 443 for HTTPS, but this can be hosted on any port between 1 to this number. So 65,535. Okay. The file name or the path is the file name or location of the resource you're trying to access. The query string is extra bits of information that can be sent to the requested path. For example, blog and then ID equals 1 will tell the blog path that you wish to receive the blog article with the ID of 1. Fragment, this is a reference to a location on the actual page requested. This is commonly used for pages with long content and can have a certain part of the page directly linked to it. So it is viewable to the user as soon as they access the page. Okay. So for example, you're like sending a link to documentation, for example, to like a developer or something, like an API docs, and then you want to grab their attention or like drive their attention to a specific field, say, on the API documentation. So you could like copy the fragment of this specific part. If you don't know what I'm talking about, then all cool. You can just ignore that, and we're going to keep going. So making a request. It's possible to make a request to a web server with just one line, get /http/1.1. But for a much richer web experience, you'll need to send other data as well. This other data is sent in what is called headers, where headers contain extra information to give to the web server you are communicating with. But we'll go more into this in the header task. So example request, this, user agent and referrer. To break down each line of this request is sending the get method. We tell the web server we want the website TryHackMe, and then Firefox 87 browser, TryHackMe on line 4, which is the referrer, I guess. HTTP requests always end with a blank line to inform the web server that the request has finished, which is this empty line here. The example response you get is something like this. You get the response headers, and then you get the body of the response. It is exactly the same thing, except you like a bunch of headers here, and then you get the content actually, which is separated by 2 lines. And then at the end, there's a blank line right here. Okay. What HTTP protocol is being used in the above example? There it is. What response header tells the browser how much data to expect? Content length, of course. Right, let's get into HTTP methods. HTTP methods are a way for the client to show their intended action when making an HTTP request. There are a lot of HTTP methods, but we'll cover the most common ones. Although, mostly you'll deal with the get and post method. Get request, this is used for getting information from a web server. Post request, this is used for submitting data to the web server and potentially creating new records. Put request, used for submitting data to a web server to update information. Delete request, deleting. So create new records, that would be post. Update your email address, that would be put. Remove a picture you've uploaded, that would be the delete. View a news article, that would be get. Okay. And then you have status codes. In the previous task, you learned that when an HTTP server responds, the first line always contains a status code, informing the client of the outcome of the request and also potentially how to handle it. These status codes can be broken down into 5 different ranges. From 1 to 199 is information. These are sent to tell the client the first part of the request has been accepted and that they should continue sending the rest of the request. These codes are no longer very common. True. You have the 200 to the 299 or up to 299 is used to tell the client the request was successful, so success. 200 OK is the most common HTTP response or like HTTP status code. 300 to 399 redirection, so the 301 redirect or the 302. These are used to redirect to another resource, can either be to a different web page or a different website altogether. Yep. And then you have client errors, 400 to 499. I think 422 is also one of the most common ones, which is a unprocessable entity, used to inform the client that there was an error with the request. And then the 500 to 599 server errors. This is reserved for errors happening on the server side and usually indicate quite a major problem with the server handling the request. Yeah, 500 errors for developers is a nightmare. There are a lot of different HTTP status codes, and that's not including the fact that applications can even define their own, which is correct. You can just send whatever status code you want in the response. We'll go over the most common HTTP responses you are likely to come across. 200 OK, 201 created. That means a new record has been created. 301 moved permanently, redirect, like permanent redirect. 302 found, similar to the above permanent redirect, but as the name suggests, it's only temporary change and it may change again in the near future. Bad request 400 tells the browser that something was either wrong or missing in the request. This could sometimes be used if the web server resource is being requested expecting a certain parameter but the client did not send. 401 not authorized, you are not currently allowed. 403 forbidden, you do not have the permission. 405 method not found or method not allowed. That means you're sending a GET request to a resource that expecting a POST request or vice versa. 404 page found. It has become a meme at this point, but 404 page not found or not found is what you're looking for does not exist. 500 the server error, and 503 service unavailable. That means the server that you're talking to, like the web server, is essentially just broken. So 500 usually indicates an application error. 503 usually indicates a server error, if you're wondering about the difference. If you are a visual learner, also check out a great http.cat resource to study status codes. Now click the view site button and looks like a browser. So HTTP cats. Processing. Early hints. 200 OK. 201 created. Okay. This is a great resource. Accepted. Sheriff, non-authoritative information. No content. Reset content, partial content. 207 multi-status. Already reported. Multiple choices. I actually never heard about these HTTP codes before. Move permanently, found, see other, not modify. Use proxy, permanent redirect. Bad request. Oh man, this is good. Payment required, unauthorized, forbidden. This is cool. For not found, not acceptable. Conflict, timeout, length required. Gone. This is cool. This is super cool. I'm gonna leave a link to this 100%. SSL certificate required. HTTP request sent to HTTPS port. Alright, this is awesome. This is super cool. http.cat. Lovely stuff. Okay, let's go to the top and click view site. Okay, so what are we doing right now? And look in the browser. Okay. What response code you might receive if you create a new user or blog post? It's 201. You've tried to access a page that doesn't exist. 404. What response code you might receive if the web server cannot access its database and the application crashes? 500. Maybe 503. Oh yeah, so 503, yeah, that makes sense because the database is like a server, and then the server is actually experiencing problems accessing that. So it's not necessarily an application problem, but rather a database problem. Okay. What response code you might receive if you try to edit your profile without logging in first? So that is going to be unauthorized, so probably 401. Cool. Click on headers. Headers are additional bits of data you can send to the web server when making requests. Although no headers are strictly required when making an HTTP request, you'll find it difficult to view a website properly. Common request headers: host, user agent, content length, accept encoding, cookie. So let's talk about accept encoding. Tells the web server what types of compression methods the browser supports, so the data can be made smaller for transmitting over the internet. Cookie: data sent to the server to help remember your information. See cookies task for more information. Cookies are one big topic that we're going to be talking about. The rest, we already know about them. Common response headers: the set cookie. Cache control: how long to store the content response. Content type: this tells the client what type of data is being returned. And content encoding, so what kind of compression it's using. What header tells the web server what browser is being used to. It is user agent. Tells the browser what type of data is being returned. It is content type. What header tells the web server which website is being requested. Host. Right, cookies. Cookies is a big topic, and I don't think this is gonna do it justice, but you've probably heard of cookies before. There's just a small piece of data that is stored on your computer. Cookies are saved when you receive a set cookie header from a web server. They even further, every further request you make, you'll send the cookie data back to the web server. Because HTTP is stateless, doesn't keep track of your previous requests, cookies can be used to remind the web server who you are, some personal settings for the website, or whether you have been to the website before. Let's take a look at this as an example HTTP request. Let's keep the view site open. Accessing developer tools. I think it's gonna tell us we want to access like a specific cookie. Okay, so here the client requests web page from http cookies.htm or THM. THM stands for TryHackMe, by the way. The server responds back with a simple web page with a form asking for the user's name. Okay, so the user is Adam, and then the server is gonna tell us to set cookie the name Adam. And then whenever we start sending further requests, we're going to add cookie name Adam into it. And then the server now is going to know that we are Adam because of the cookie. This is the most basic form of using cookies, and please do not use it like that whenever you're signing users in, because this is grave. And the reason for that is that you can easily view what cookies your browser is sending to the website using the developer tools. If you don't know how to do that, right click, go to inspect, and then click on application. Cookies, just expand that cookies, and then you have TryHackMe. And in TryHackMe, you can see that we are sending all of these cookies whenever we access TryHackMe. Okay? It's used to save cookies. So this is how you can like check different cookies that are being sent. I have these open because I do have Google and YouTube open on my browser. And also in this specific session, we are using YouTube. So there's a YouTube video here. So we did make a connection to YouTube. That's why YouTube was there. And probably YouTube is talking to Google or something. So which header is used to save the cookie? Set cookie. Right, making requests. Click the view site button on the right. This is an emulator for making demo. Would you like to get it and learn how to get started? No. Make a GET request to /room page. Oh, there we go. Click go. THM, you're in the room. Pretty sure this is it. Make a GET request to the block page and set the ID parameter to 1. ID equals 1. Go. There you go. Make a delete request to user 1 page. Delete user 1. Boom. The user has been deleted. Boom. Make a put request to user 2 page with the username parameter set to admin. Okay. So user 2 and then username is admin. Oh, I had a typo there. What? With the username parameter set to admin. Isn't this what we're looking for? Use the gear icon to manage body parameters. Oh. So name or username, admin. Save, and then it's gonna add it here. Okay. Go, username change to admin. Make a post request to the login page with the username of THM and the password of let me in. Okay. So we are talking about a post request. We're sending it to the login page. And then in here, we're sending a username to THM and a password of let me in. Go. HTTP request master. Awesome. We got everything up and running. We are webbed. And this is it. So we are in good hands right now. We have finished our HTTP. And we now know HTTP in details. And we know DNS in detail from the previous video. If you haven't watched the previous videos, I do recommend that you do. I do have a playlist specifically for how the web works. Before that, I do have a playlist for for networking, which is also very important for you as a hacker to know. Thank you for watching. Let me know if these videos are helpful to you. Give me a like, give me a subscribe, give me some constructive criticism in the description, in the comments below. I'm going to leave the http.cat, or you can just visit it yourself, but I'm going to leave a link to it right here, which is super duper fun. And thank you for watching. I will not be repeating myself and all of the outro again in every video, where I ask you to give me constructive criticism and what you would like to see in these videos and if I'm doing a good job or not. So just watch my previous videos and watch this video. And if you have any comments, any constructive criticism for me, let me know in the comments below. Thank you for watching, and I will see you in the next one. See ya.